In this chapter, we will be studying quadratic functions. In this lesson, we're going to use what we've learned in previous lessons to solve word problems that ask us to find the maximum or minimum value of a variable. Okay, well, in a previous lesson, we looked at maximum, minimum word problems, but we were looking at area problems and relationships between numbers. Now we're going to look at revenue and projectiles, okay? And we're going to start with revenue here. Now, bear in mind what revenue is. If you want to think about the formula here, it's the number of items sold multiplied by the price per item. Revenue is the amount of money that you take in. Okay, so just to give you a quick example here. Let's say that you sold 10 t-shirts and they were $5 each, right? $5 per shirt, 10 shirts. How much money did you take in? Well, you took in $50. Now, this is not profit, okay? Because profit, you'd have to subtract expenses here. No, this is just how much money did you take in. That's it. That's all we're interested in here. So let's take a look at a couple problems that deal with revenue. So an amusement park charges $8 for admission and averages 2,000 visitors per day. A survey shows that for every $1 increase in admission, okay, 100 fewer people would visit the ride. So we're going to write an expression here for the park for how much money the park takes in a day. Now, this is one of those questions here where it's almost more difficult to let x be a specific variable first. You almost got to sort of write the equation until you run into the need for a variable. And by the way, you will right away, and I'll show you in a second here. But let's just take a quick look at this. So revenue is, remember, it's going to be the number multiplied by the price per unit. That's a terrible way to write that, but anyway. Actually, I'm going to zoom in a little bit so you can see that clear. So it's number times price per unit. Now, what we do here is we're going to put this into two different sets of parentheses here. So how many did they sell here? Well, we are told they sell 2,000 per day. How much does it cost per ticket? Well, it's $8 per ticket. But they're going to change something here. A survey shows that for every $1 they add to admission. Now, where's admission? Where's the admission price? Is it here? Is it with the 2,000? Well, no, this is people. This is money. So I'm going to add $1, and every time I do that, now, and that's the trick here, for every time you do this, in other words, I don't know how many times I'm going to add $1. There we go. So x, we're going to let x equal, okay, we're going to let x equal the number of $1 increases in price. That's what x is. Now all of a sudden, this is where I bumped into the need for that variable here. Now, every time I do that, I'm going to lose 100 people. Every time. So that's why I have to put that 100x there. Okay? So 2,000 minus 100x multiplied by 8 plus 1x. So there's a change. So again, here's the number of people showing up, but it's altered a little bit. I'm gonna subtract 100 every time I add the 1 here. Now over here, this is the initial price, and I'm gonna alter it. Keep the money separate from the people to start off with. Okay? Now, what I'm going to do here is I'm going to expand this all out, and then we're going to complete the square because I want to know how to get the maximum revenue here. So 2,000 times 8, that's going to be 16,000. That's going to be 2,000x minus 800x minus 100x squared. Now, I'm not particularly fond with the way that's written, so I'm going to rearrange this a little bit. Put the negative 100x squared up front. What do we got here? 2,000, right, minus 800. Okay, that's going to be your positive 1,200x, and then I'm going to move that 16,000 to the back. Now I'll complete the square. First thing I'm going to do is move that 16,000 out of the way. And then I'm going to take the 2 out of that linear term, and I know that's going to leave me with, oh, sorry, man, I can't believe I just jumped right into that. See, it's so easy to make that mistake there. You've got to be really diligent with that. Man, that was a really good example of a problem that could show up here. First thing you got to do is take that leading coefficient out. Negative 100, this leaves us with x squared minus 12x plus the 16,000. You know, I would have run into this if I hadn't I caught that right there. I would have caught it very soon, because if I take a 2 out of that 1,200, I'm going to be left with 600, and then I have to square that. Well, that number is just going to be ridiculously large. And when I start to when I think about the scenario that I end up building here, that number's way too big to be reasonable. So anyway, bear in mind we got to take out that leading coefficient. I got to take it out of both of those terms here. They both become much smaller, much more reasonable. I'm going to take a 2 out of that 12. That's going to leave me with 6x. So I know 2 steps down, this is going to be x minus 6 squared. And what I got to figure out is what number's being added on at the end. But this is substantially easier, because when I square the 6, I'm going to get 36 minus 36. And then I'm going to take the negative 36 out, because I don't need it to complete this perfect square. So negative 36 times negative 100, that's going to be positive 3,600 plus 16,000. And so putting that all together, we're going to get, what is it, 19,006, whoops, not 196,000, too many zeros, 19,600. All right, so the vertex here is 6 comma 19,600. Remember, this is going to be x, and then all the way down, and I didn't write it, but it's implied, all the way down these were r's. Okay, all the way down those were r's, which means this is going to be my r variable, x comma r. There is no y here, x comma r. So what's my maximum revenue? $19,600. What admission cost gives us the maximum revenue? Okay, now don't go weird on me here. Don't say, well, it's going to be $6. No, it's not. X is not the admission cost. Okay, it's not. X, remember, was the number of $1 increases in price. So think about it. I was increasing the price. It started at $8. I'm increasing it to 6? Well, that doesn't make any sense whatsoever. Like, to use that number as this answer here really doesn't make any sense logically at all. Okay? So what's happening here is I've increased it by $1 6 times. So $8 plus $1 6 times. The admission price here is $14. Okay? Now, how many visitors would give you that maximum revenue? Okay, well, bear in mind that we just discovered here that when x is 6, we get the maximum revenue. So we just go back up to here. This is where I'm getting the number of people. So this right here is where I'm getting the ticket price. This binomial right here is what's giving me the number of people. So if you plug x into that, okay, 2,000 minus 100 times 6. And that's going to give us 1,400 people. That's how many people are going to give us the maximum revenue. Okay? So I hope that makes sense as we walk through that. It's a good problem here. Tell you what, let's take a look at this next one. Okay. It says team photos sell for $10 each, and on average the coaches sell 30 photographs per team. So this is giving us an initial situation here. The coaches do a survey and find that for each reduction in price, reduction, we're going to be losing money there, of 50 cents, an additional 2 photos will be sold. So at what price will we get the maximum revenue? Okay. So once again, we're going to get the number sold multiplied by the cost here. Now I'll zoom in a bit. So what was the initial situation here that we had? Well, the number sold, how many were we selling? We were selling 30. I'm going to give myself some room. and we were selling it at $10 each, and now we're going to make an adjustment here. We're going to reduce the price by 50 cents, but we don't know how many times we're going to do this. So this is where we're going to introduce x here. We're going to let x equal the number of 50-cent decreases. Okay, so you can't quite see that. The number of 50-cent decreases in price. Okay, that's my x here. So boom, there we go. Now every time we do that, we're going to increase our sales by 2. So I'm separating the number being sold by the price, okay, per photograph there. So don't try to remember, don't mix in the parentheses here, don't mix up the money and the number of people here. Now, let's expand that out. 30 times 10, 300. 30 times negative 0.5 will be negative 15. Positive 20x. And then negative x squared. And then I know people are going to want to have this in the right order. So negative x squared plus 5x plus 300. Now, I'm going to complete the square on that to figure out what price is going to give us the maximum there. So first thing we're going to do is move that 300 out of the way. Then I'm going to factor that leading coefficient out. Now, it was just 1, but I got to be careful about that. Make sure I do it. Now, we haven't seen this in a while here. I'm going to take the 2 out of there, but 5, that coefficient of the linear term, it's not an even number. So when I do that, I'm going to get 5/2 x. Okay, which isn't awesome, but it's okay. Okay, I know that down here, that means I'm going to get negative x minus 5/2 squared. And then I got to figure out what's going on over here. So I'm going to add that number squared. But if you remember what I did before, I'm not going to convert that into 2.5 and then square that. I'm just going to leave this as 25/4 minus 25/4 because it's just easier for me to do that. Okay, just square the numerator, square the denominator. Done. Now I'm going to take the negative out, so it'll be negative x squared minus 5x plus 25/4. And then this is going to be plus 25/4 plus 300. Okay. Now, I need a common denominator. And the common denominator here is going to be 4. So it'll be 1200/4. So this will end up being 1225/4. Okay. Now, my vertex here is going to be the values 5, 2, 1225/4. There's my vertex, and the variables here are going to be x and r. Now at this point here, that probably doesn't make a whole lot of sense to leave it like this. Now we probably do want to put it as the vertex. That's going to be 2.5, and 1225 divided by 4, what have I got here, is $306.25. So now what is this telling us here? Oh, sorry, x doesn't equal both of those. I got to make sure I get this correct here. My revenue, my maximum revenue will be $306.25. So remember, x isn't given in terms of dollars. That's not what it is. It's the number of 50-cent increases. So what price are we going to use here? Well, our price was determined by this binomial, 10 minus 0.5x. So let's do that. So our price here is going to be 10 minus 0.5 times 2.5 in this case. Now I don't want to write this down wrong here. So my price here when I plug that is going to be $8.75. Okay? That's the price that's going to maximize our revenue, and then the remainder of the question says, at what price will the revenue be maximum? Boom, there we go. How many photos will they sell? Well, remember, this is the number of photos that they're going to sell. So the number is going to be 30 plus 2 times 2.5, whoops, 2.5. That's a little easier to do because I already know that 2 times 2.5 is going to be 5, so this will be 35 photos. That's the maximum number. All right, now we're going to look at a couple of, we're going to look at a couple of projectile problems. Now, I realize that there are some people that are not in my class or even at the school that I teach that are going to be watching these videos here. So just to be clear on what's going on here, the expectation where I work here is that when we move on to a projectile problem is that you're actually going to use your calculator to solve it, okay? That these will typically not be done algebraically, mostly because of just kind of the nitty-gritty little questions that are going to get asked. And we won't take a look at how to solve some of those things algebraically until later. But we also do want people to know how to use the calculator. So we use this opportunity to demonstrate that. So in this type of problem. So here we go. A ball is thrown into the air from an apartment and falls to the ground. The height in meters h of the ball relative to the ground, t seconds after being thrown, is given by this right here. So we're going to find the maximum height of the ball above the ground. Now, I can complete the square on that to get the maximum. That's not the problem here. But what we want to do here is we want to actually use the calculator and talk about how you do that. Okay, so we're going to enter that equation in. So again, maybe if you've just turned on your calculator, you get right here. So from your home screen, because I know some of you will not have worked with your calculator all that much, we're going to press y equals to enter in this equation. Okay, so -5. So down there is your negative, right? Don't use this. This is your subtraction. Here's your negative. -5. Now, in my equation, I see a t squared. I could actually use t squared here, but what I want to do though is not use that. I want to use the button the calculator uses for its independent variable. That's, whoops, this button right here. Okay? It's got an x, a little t on it, a theta, and an n. Now when I press it right now in the mode that your calculator will default to, it's going to go put an x there. And that's okay, that's what I want. So x squared, okay, plus 10x plus 35. Okay, so I've entered that in. If you've played with your calculator before, if you've changed some of the settings here, like normally what we would do at this point is we just press graph here, although I suspect my calculator is going to be all off. So what I'm going to do here is I'm going to press the zoom button, and before I start anything I'm going to press zoom number 6. So I'm just going to press number 6. That'll take me to zoom standard, which takes us back to like the factory default settings for this. Okay, so notice that my graph goes up, comes down, but it goes up quite a ways above the graph here. Okay, I know that it's a parabola that's going to open down because the leading coefficient here is negative. Now I'm going to adjust my window. So I'm going to press my window settings because I want to be able to see what's going on. Now my window settings default horizontally to -10, +10, going up by 1s. But I really don't need to go down to -10 because it doesn't make sense in this question to be talking about time prior to 0. Because bear in mind, x is taking the place of time here. So I'm just going to make my x minimum 0. It also doesn't make sense to talk about the value of height less than 0 because I'm assuming that this ball is not going to start burrowing through the earth. It's going to hit the ground and that's where the parabola is going to stop. So I'm just going to put 0 there for my minimum. Now what I don't know is my maximum. I don't know what the maximum is supposed to be. In fact, that's kind of the point. We're going to use the calculator to find that maximum. So what I got to do here is open up my screen here, move that up so it's high enough so that I can at least see it. Now this is just guesswork. So I'm going to put a 50 there to start off with. Let's grab it. Oh, there we go. 50 was good. 50 worked out pretty good here. So I can now see the vertex. To find the vertex now specifically, what I'm going to do here is press second trace. Now you may have done this before. If you press trace, you're going to get the little cursor on the screen here, and then you can move that cursor back and forth. Okay, my cursor right now is off the screen. If I move that back on here, I can move that cursor and it gives me the coordinates right there. Maybe I'll even just zoom in here. But that's actually not helping me as much as you want here, because when I move that cursor up to here, I'm not entirely sure if I'm getting the exact maximum that I want here. In fact, I'm not getting any nice values there at all. It might not be a nice value, but in this particular case, I actually know that it is. So I'm just going to zoom out a little bit so you can see what buttons I'm pressing. I want to press second trace to get into what we call the calc menu. and I'm going to use the maximum feature because this parabola opens down. I'm looking for the maximum value, so I'm going to press maximum. Now I'll zoom back in. It's asking me for a left bound. So what I'm going to do is I'm going to move my cursor, and in these cases right here, I'm just going to use the left and the right buttons here. I'm going to move my cursor to the left of the vertex and press enter. Now depending on your calculator, it might just put a little triangle there, but it might draw that line there. Then I'm going to move the cursor to the right of that vertex. So it's going to drop down a little bit, press enter again. What I need is I need the vertex to be in between. So I just want the vertex to be in between these two boundary points here, okay? Because the calculator is going to start to kind of zero in on it. Now the calculator is asking for a guess. It's asking if it can use this as a guess here. Don't worry about that. Just press enter to get past it. All the calculator is really needing here is a initial starting value, and it uses this guess value to quite literally zero in, kind of spiral in on the correct answer. And it's basically just taking the position of the cursor wherever it is right now. So just press enter. You can see it think for a little bit, and then we get this 0.9999995, comma 40. Now, when I see that right here, that's 1. Okay, that's going to be a 1, comma 40. When it gives me values like that, it simply tells me that the calculator couldn't quite get it to exactly the number that it was looking for, but it just got it ridiculously close. So what's the maximum height the ball is above the ground? Well, that's going to be the y coordinate. So that's going to be 40 meters. How long does it take to get to the maximum? That'll be the x coordinate, 1 second. Okay? So immediately I get two answers to two questions and just use the calculator. Let's zoom out a little bit here. Whoopsie daisies. Now the question is, after how many seconds does the ball hit the ground to the nearest hundredth? Okay, well, hitting the ground here, down here, this is where it hits the ground. So what I'm looking for here is the x-intercept of the graph. Now, second trace gets us back into the calc menu where I can do calculations on the graph. What I'm looking for is the zero of the function. Okay, because that means the same thing. The zero of the function is the same thing as the x-intercept of the graph. Zero of the function. So choose 0. And what I've got to do here is I've got to, same thing I did with the maximum here. My 0 is roughly here. Now I can't get the calculator to hit it exactly, but I'm close. I'm going to use the left key to move the cursor to the left of it, press enter. And then I'm going to move the cursor so that it's to the right of it. Now notice that the cursor drops off the screen there. That's okay. As long as it doesn't go left or right of the screen, I'm fine. Going below the screen is okay. Going above the screen is okay. It's left and right that the calculator doesn't like. So I'm going to press enter. As long as that x-intercept is in between those two boundary points. Now it's asking me for a guess, but I can use whatever guess the calculator is starting with. Just press enter. And I get 3.828 blah 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 comma 0. Okay. Well, that doesn't look like that was attempting to get to a number like that. It's not like 3.99999. 3.8. Okay, so I'm okay with that. Now it says to the nearest hundredth, so 3.8, round that up, 3.83 seconds represents where it's going to hit the ground. Now, how high is the balcony above the ground? That's my next question. How high is the balcony above the ground? Well, the balcony is where this thing was thrown from. So that's going to occur right there. So that's going to occur at the y-intercept of the graph. Okay, so how do I get the y-intercept? Again, let's zoom out a little bit here so you can see the buttons. I'm going to press second trace once again to get into this particular menu here. This time I'm going to use the value. The reason I'm going to use value here is because as soon as you do that, the calculator opens up the screen and it's waiting for you to enter in what the x value is. Well, I know what the x value is at the y-intercept. That's a definition thing. At the y-intercept, the x value is 0. So you press 0. And then I'm going to zoom in a little bit here. And when x is 0, y is equal to 35. That's the answer we're looking for. So how high is the balcony above the ground? 35 meters. Okay? Good. Let's do another one. Get one more. I got to zoom in a little bit here. So a Frisbee is thrown straight up in the air from a position 2 meters above the ground. And we got the height after t seconds is given by this guy right here. What is the maximum height the Frisbee will reach? Okay, so we're going to enter this in. So I'm going to go back to y equals. It's going to take me to my first function. I'll press clear to get rid of that one. And now I'm going to enter in this equation. Okay, we'll zoom in just a little bit so you can see that. So it's got to be 2 plus 6x minus 2x squared. 2 plus 6x minus 2x squared. Okay, I've entered that in. Now, I'm assuming I'm going to have to change my window settings, that what I just had from the previous question won't make any sense here. So before I do that, I will press zoom number 6 to go back to the factory default settings. That's going to be the negative 10, 10, negative 10, 10. Okay, so number 6. Just see what it looks like from here. Ah, okay. Actually, I can see everything I want to see right there. Now, but I don't want to do anything kind of goofy, so I'm going to go back into my window. I don't need it to go, I don't need my time to go less than 0. I also don't need my height to go less than 0. So I'm going to graph it like that. There we go. Everything I need I can see right there. So the question is asking, what is the maximum height the Frisbee will reach? Okay, so I'm looking for the vertex there. So remember what I do. Second, trace, gets us into this menu where I can work on the graph. It opens down, so I'm looking for the maximum. So I got to find the left bound and the right bound. Okay, so I got to move my cursor so it pops up on the screen there. There we go. So there's my vertex roughly. Using just the left and the right keys, I'm going to move to the left, press enter. Move it to the right, press enter. So as long as my vertex is in between those two boundary points, I'm okay. I'm not going to worry too much about the guess. Press enter, it thinks. And what have I got here? 1 point, okay, well that, with that 9999, I'm assuming that I got to round that there, so 1.5, 6.5. So the maximum height the Frisbee will reach here is going to be 6.5, whoa, why did I put the decimal so high? That was weird. 6.5 meters. The next question said, how long will it take before it reaches the ground? Okay, well actually, I want to answer this other one here. It hit 6.5 meters at 1.5 seconds. Now the next question says, how long will it take to reach the ground? Well, that's looking for that value right there. So remember, second trace, that's going to be the 0 of the function, because it's the x-intercept. Those are the zeros of the function. So I'm going to move my cursor down, again, just using the left and the right keys. It's right about here that my cursor kind of disappears. So I'm going to move it to the left a little bit, press enter. When I move it to the right a little bit, it's going to disappear below the screen. That's okay, press enter. So as long as it's in between, press enter again. And what do I got here? Okay, to the nearest tenth, I believe this question asked for, so 3.3. After 3.3 seconds, it hits the ground. Wonderful. Now, last question here. If it is caught 2.5 meters above the ground, how long will it have been in the air? If it is caught 2.5 meters above the ground, how long will it have been caught in the air? Okay. Now, 2.5 meters, when we give you that information here, think about that. That is a height. That's kind of taking the place of the y coordinate. Think about your function notation. That's the y value. Well, where on your calculator do you enter y values? Well, right here, y equals. So press y equals. I want to leave my function in there, so I'm going to go down to y, the second y value, and I'm going to enter in 2.5. Okay, and when I do that, okay, when I do that, it goes across right here. Now, this is intersecting my graph here in two different places. Now, I'll be honest with you, that it doesn't make much sense to catch it here. That kind of meant that you threw it up and immediately caught it there. Now, maybe you did. But I think the question is implying this point of intersection right here, and I want to know when that happened. Now, to find that point of intersection, you press second, trace, and we're going to go down to intersect. Number 5, intersect. Now, the way this one works here, the calculator here, and I'll zoom in on this, the calculator asks you for the first curve. Now, you got to be kind of careful. What you want to do here is make sure you're on the first curve, and there are only 2 curves that I've entered in there. Make sure you're just close to the point of intersection that you're interested in. Now, I'm going to press enter, watch what happens. Yes, I'm on the first curve. It drops me vertical to the other curve here. Now, I know it's a straight line, but in math, anytime you graph something, you call it a curve. Okay, whatever. So, is that the second curve? Yes. Still needs a guess, but just press yes to get past it. And it tells me that that point of intersection is going to be 2.9, comma 2.5. That's the time that it was caught at. Okay? So, how long was it in the air? 2.9 seconds. Or, this is the answer that makes the most sense. Or, it could have been this one right here. Now, if there's another point of intersection, we press second, trace to get to that menu. We're going to look for intersect again. This is number 5. Now I'm going to move the cursor close to this one. Now this one really doesn't make much sense, but I'm going to find it anyway. So I move the cursor fairly close. Doesn't have to be right on, fairly close. Am I on the first curve? Yes. Did it jump to the second curve? Yes. And again, press enter to get past the guess. And it moves us right there. Now, what's that point of intersection? 0.085, blah, blah, blah. So 0.09 seconds. So 0.09 seconds. Now, that seems kind of ridiculous. This one makes way more sense, but those are my 2 possibilities there. Okay? Whoops. So, anyway, just a little bit of practice with the calculator. I hope that gives you a little bit more knowledge as to how the calculator works, and so you're a lot more comfortable going in. Because bear in mind, even for those other word problems, you could always use your calculator to help confirm what your algebra is telling you.